Hey, um, hmm, one moment. I seem to be frozen. All right, there we go. All right, now it's working correctly. Sorry, it took a second. Anyway, welcome to another Notional Pipe Stream. We are going to, for anyone who's been following up to this point, but maybe missed the last session or anything, we're doing the leg component of our componentized system based on our plugin Contour Rig Tools. Um, And what we are going to be mostly focusing on today is adding IK to the leg, driving that with the inputs to our component, and how elements that aren't just what we've seen so far, which is essentially, contour, joints, and bones being driven by a component actually function when hooked up to the inputs that the component receives. And then, if we have time, we'll start adding the leg to the body plan and stuff. But before we do that, I know Tagore has a few things that he wants to say too.
Yeah, thank you very much, Ralph. So a couple of things we just kind of want to mention at the beginning of the stream is that something that we've been talking about for a while that we are going to be starting to do, I think, is that we're going to be start offering some consulting services, especially in the area of web graphics. And this is something that we're just getting started with. So we don't want to talk too much about it right now, but if you are in the market for services like that, or if you happen to know anybody who is, um, definitely feel free to get in touch with us. And I think that's pretty much about as much as we want to say right now. But we
Yeah.
did just kind of want to throw that out there.
Well, and I think it's worth mentioning that, what we are known for at the moment is, all of our animation related tools, right? And it might, and this is a bit of a different thing, but part of the reason for that is that while my expertise is really centered wholly on sort of the animation and rigging world, this is very much not true of Tagore. He is a very experienced web programmer. So, Notional Pipe may end up doing a variety of things, and, web graphics may well end up being like something that we want to do too. Um,
Yeah, I mean, I would say that in a lot of ways, especially between Raf and I, we have some expertise that I don't think is very common. And in particular, I've done some pretty sophisticated stuff related to data visualization, and especially in a previous job, I think pretty much pushed the browser to do things that browsers generally don't want to do. So it is something where we have quite a bit of expertise. I also wanted to mention that I have started a stream about programming, and right now we haven't promoted it very much. But if you're interested, um, certainly come by. It's starting with the very basics, and it's done in a very Socratic style. I'm talking with someone who has basically no experience programming, and I'm teaching them to program. And a lot of what we're doing is really starting from the fundamentals. So it's not very practical, but I really think that getting a good foundation in computing is very valuable if you want to be a programmer. And we've talked about this a little bit, that it's extremely useful to be able to program a little bit in order to be able to rig. So I'll drop a link to the channel um, into the chat. And I'm streaming on Thursday nights at 8 o'clock every week. So feel free to come by. Feel free to say hi. And yeah, that's pretty much what I have to say about that as well.
yeah. You should probably mention the name of your channel.
The name of the channel is the Mapping Reduction, but I'll drop a link into the comments, into the
Yep.
chat.
And I also was going to say to that, one of the things that wasn't very evident to me when I first started to learn to program, right? Partly from Tagore, because, Tagore and Brian, my partners in Notional Pipe, were already working at Ansevin Studio at the time when I started trying to dip my toes into that, right? So I had people who could teach me, but I didn't come to understand, and the componentized rigging is a perfect example of this. A lot of really beneficial things about rigging until I started to understand some programming concepts. And so one reason why I think it would be highly beneficial for people to learn sort of the base concepts of programming, not just like the surface level, like here's how to do a really quick like couple of Python commands that are useful to you. I mean, that's useful too, right? But the actual sort of conceptual basis of things that Tagore teaches is that you come to understand things you wouldn't necessarily understand otherwise, and especially for riggers, I think that's actually a really useful thing. Like it made an enormous difference in my understanding of how to organize rigs, and what it meant to think about the data flowing through rigs, and that led directly to me understanding sort of like, I mean, I certainly, you know, the componentized approach was pioneered, I think, mostly by Raphael Fragapane, whose name I probably mispronounced, and I apologize. But I wouldn't have understood why that was important if I hadn't had some schooling in like programming concepts. So yeah,
Right.
this is one reason why I think, you know, it's really beneficial for people to learn that stuff.
Right, and it's worth mentioning that he's actually he's a really accomplished programmer.
Yeah.
You know, I've talked with him a fair bit, and certainly he has an awful lot of background in some things that seem kind of obscure and not even all that practical, but that turn out to be pretty useful. And so yeah, that's kind of what I'm doing with the stream, which is there's a lot of information out there about how to do this as a programmer, right? Like how to do this one specific thing. But what I'm doing is really kind of trying to start at the beginning and really build up the foundations, because when you have the foundations, it's pretty easy to learn the specifics of systems, but it's a lot harder to work backwards from learning the specifics of systems and getting the foundations. So that's what that's about.
So anyway, returning to building this leg. So as you know, last time, and you know, depending on whether you're reviewing that or not, I have moved to using more functions that I've written in Python to help me assemble these components, because I was getting real tired of doing it manually. That can be very painful. So I am going to be doing that, but it is all sort of just ways of accelerating things you could do by hand. And I've sort of shown how to do some of this stuff by hand in earlier streams, so I think it's okay for me to be doing a bunch of this stuff with some code. But to start off with, where we left things last is we'd gotten all of these bones and joints and stuff to adjust themselves appropriately based on the inputs the component is receiving. You know, like I can go move this knee around, and what is actually happening here is that the bones are changing their length and changing the next joint orient such that they will always conform to the the placement of these guides. And the placement of the guides is flowing through the inputs that this component can explicitly receive. So we need to do a similar thing, but we need to do it for the IK controls that we are now going to be adding. We don't really need to, and this is a very contour-centric thing. If I was doing conventional rigging, I would also be constructing a separate hierarchy of FK controls. Since in contour, bones can behave essentially as FK controls, sort of cutting out the middleman there, and the IK handles the blend between them automatically. I don't really need to consider any of that stuff in terms of the component. Just as we saw with the finger, if the leg was purely FK, this would be finished. Well, I mean, it wouldn't really. I'd have to add some circles to it and stuff, but, you know, mostly. But it's not. It's a foot. So there's a couple of things that I'm going to do in terms of where I place these foot controls, and sort of how I deal with the question of where they ought to go. And one question that immediately comes up whenever you have a foot is, where are you going to put the pivots for essentially the main foot control? And anyone who's used the setup machine knows that I used to put them like back at the heel. Like, there's no real definition of where the heel is here because there's no actual mesh attached to anything. But you'd have the base pivot of the foot like back here somewhere. And I ended up deciding that was actually not desirable for a couple of reasons. One of which is it makes the rig more complex, and I do want to avoid complexity wherever I can. However, if it was really, really, really the right thing for animators, I would go ahead and do it even if it was more complex, because that would be beneficial to people's workflow, right? However, I came to believe that it actually isn't. And the reason for that has a lot to do with what your rig assumes, the assumptions about what the animator is going to be doing with the rig. So the whole idea about putting that pivot point back at the heel is that there's this assumption that, like, well, what your character mostly does with their feet is walk, right? And every time you walk, you've got that strike pose. Like, I don't know if you can sort of imagine my arm as the ground, and you like strike the ground and then put the foot down. However, as I animated more, and as I did more and more complex shots, I came to realize that was really, like, there really wasn't a general case where you're like, yes, this is always where the pivot should go, it's always the heel. Because honestly, your foot does all kinds of things. You pick it up, and move it around in all kinds of ways. It contacts the ground in all kinds of ways. That particular strike pose that you see in your classic walk may or may not occur, depending on exactly what your character is doing. And the presupposing this specific set of actions came from an earlier view that I had, and that I think people often have, right, about how to construct rigs, which is that you're aiming them at this very specific thing that you're imagining the animator will do. You know, you have a foot rig, so you're like, oh, well, you know, walking is what this is, you know, like, oh, I mean, that's what you do, right? But in fact, characters do all kinds of stuff, and walking is not necessarily, I mean, yeah, characters walk, obviously, but you're essentially, anytime you decide where to put that pivot, you're making trade-offs. You're saying, I'm going to make one thing easier I'm going to make other things harder to make one thing easier. And I ended up feeling that that wasn't actually a worthwhile trade-off. Now, of course, if you don't want to have trade-offs, there is a solution to that. It's called ephemeral rigging, right? Where you are free to manipulate things in a wide variety of different ways, and it's perfectly okay. But we are dealing with conventional rigging, which means that you're gonna end up having to trade off one way or another, because even if we had the ability to have multiple controls that switch pivots or something along those lines, it adds a lot of complexity to the rig. And then in addition to that, it means that the animator has to manage mentally what that means. So, so what we're going to be doing is putting our main control right here where the angle is, because ultimately what I came to feel was that of all the places you could put it, that one was actually the most reasonable, right? You know, and to set that up, what I'm going to do, why don't I just start by I'll make this control manually, and I'll just make like a NURB circle here. And one of the things I've just started doing, because it's quick, basically, is that I'll often make IK controls diamonds. People have different sorts of conventions for what controls look like, and I'm not necessarily going to insist on any particular convention for that. I actually think it is largely not actually particularly germane, especially because I really like to use character maps and hide the controls when I can. But you want to have at least some kind of sense of like, oh, well, this is a diamond, it must be an IK control, you know. And let's buffer it, and let's call this one, foot control and foot buffer. Or actually, I've been calling them buff these days. And here's where some of our code is going to be really helpful, because here is what I can do. I can say, remember all this stuff we did last time where I discovered that some of the code that I wrote didn't actually work because I cobbled it together from 10 different places? Well, now that it does, this is probably hopefully going to be real easy, right? Because we can compose some of these functions together to basically make what we want. In this circumstance, actually, in this particular case, it's really straightforward, because all we actually need to do, and I'm actually only going to need to use decompose matrix input, because all we actually need to do here is to put this at the world space location of the ankle. So this one's real simple. Let's grab the inputs. Right, I put them in component. The hierarchy is a bit of a mess right now. I'll clean that up in a second. So I'm going to say, and as you may also recall from last time, I have a little bit of a shorthand that I've created for myself. So S1 is a function that is equivalent to pa.selected and the first item in the selection list. And this just lets me like write stuff more easily, right? So I'm going to say S1, actually I gotta import that. I'm going to put this on my other monitor, and you won't be able to see it. I apologize for that, but there's not really a great way to deal with this with one monitor. Import component utils. Utils dot. Actually, I am going to give that another name. That's our inputs dot ankle. That's the one that we are decomposing. And then since it's going to give us our decomposed matrix, we can simply say, or rather our decomposed node, we can simply say output, oh, actually, one second. Yeah, drive with matrix. That's the one I want, because that one does these bits of it for me. All right. And I give it the matrix input, and then I give it the target, which is S2. There we go. Now, this one has assumed the orientation, as well it should, of the input that's driving it. Now, here's where we end up with another choice to make, which is, do we care about these IK controls having their translate attributes aligned to world? And I'm actually going to say we probably, for purposes, no, for the wrong one there. Sorry, I meant wanted to be pointing out normal X. There we go. For our purposes right now, for this, we may decide that I actually do want to. But for our purposes right now, I'm not going to worry about that. And just to give you an idea of why that matters, right? If you're animating a walk cycle, and you're like, my character is going to, this cycle is going to get repeated like 10 times into the scene or something like that, it is actually very helpful if all of your controls are aligned, like their buffers are aligned to world space. Because that way you can say, if I'm going X number of units, like down the Z-axis or whatever, it'll mean the same thing for all IK controls. I'm not going to worry about that right now. There is a solution to that problem. It's kind of obnoxious, and I'm not sure if that's going to matter for these rigs, because they have a lot of space switching anyway. So, I'm going to ignore that for the moment, but we may come back to that. Alright, so here is our foot control, and because the buffer is being driven, it means that as I move the ankle around, the base foot IK control remains in place. Now let's take a look at the ball roll control, because this is a reverse foot rig, right? We need one of those two. Gonna do the same thing. I don't even know what it does if you give it sections of one. Probably refuses to do anything at all. Now in this case, we're going to have something that is parented to the foot control. Oh yeah, also this circle has to be pointing down X, since as I've mentioned before, we are expecting for these rigs to always point down X in terms of chains. And I think it's always good to be consistent about that within a given rig or project. Obviously, people can do it in different ways, given the project. But here we have the ball control, and we've got to put it at the position of our ball input. But we need to do it in the space of the foot control. So we're going to be, in this case, doing something slightly different than what we did previously, and do matrix in space S1. Let me select the inputs. Select this. So the matrix is going to be that is going to be ball. But then the input, the space input is going to be ankle. Because if the if the ball control is parented to the ankle control, we need to give it a matrix that is what it would be relative to the ankle in order to place it properly based on the guides. This is all stuff that I did manually in previous streams. It is, despite the fact that I'm kind of looking back and forth because I haven't done this in a while, reminding myself what the functions actually say, it's much easier to do this than to hook up all the things. So this would give us a input, and we could then drive with matrix. That and our second. Oh, this won't work. That's right. We're going to have the problem of, I should probably fix that at some point. We're going to have the problem of the selection changing out from under us. So actually, I'm going to do something slightly different. I'm going to say, input node target node equals s, which is my alias for pa.selected. Here's a little thing you can do in Python 2, you can't do in Python 3, is use the, basically pretend that you're writing JavaScript or some other language and stick a semicolon in there for another line. I'd never do this if I was writing actual Python code, like that meant to be reused. It's only useful in the command line. And in that case, we can say input node dot ball and input node dot ankle, and our target is target node. Let's see if this works. Let me make sure I get the correct number of parens. No, I also misspelled it.
I actually had no idea that you could do that with the semicolon.
Oh, you can actually. They took it away, which maybe wasn't the worst idea. Actually, taking it away, because it is super weird and like very much unPythonic. But you can, and it's occasionally kind of useful in a command line.
Okay, yeah, I mean it's useful. It is a little weird though.
Yes, no, it's super weird. Well, especially because you can in Python 3 like put 2 lines on 1 line, right, using like slashes or something, but it's awkward. I actually kind of like that, even though I think anyone who's tempted to use that in an actual like in the context of writing actual code, it should not. Right.
Don't do that. You wouldn't do that. You
don't do that. Right. Exactly. All right. So this, and that just worked, right? Occasionally things just do. We've got the foot and the ball control being fully controlled. Yep. There we go. Ball is what it's going to be relative to the foot, regardless of how I move these things around. This is the really nice aspect of that componentized concept, right? Everything's based on inputs. If you get that all figured out the right way, you don't really need to worry about how that data is getting set or rebuilding stuff to change that data. It's just all flowing through properly. Now, the last control that we're going to have to add here, that's sort of part of our reverse foot control, is going to be the toe, because we're going to need to rotate the toe. Now, this is going to be an interesting case, actually, because what we need to do for the toe is actually have a pivot point at the ball, right? Because if you think about it, you've got an IK toe. You want to be able to rotate the ball back from here. Now, obviously, if this system were ephemeral, right, I'd be able to rotate the ball of the foot and it would move the ankle around and maintain their relationship at all times. As it is, I can't do that because this is a conventional rig and you cannot have bidirectional anythings. Or at least you can't do that without serious additional work and complexity. And kind of cheating it. And so, yeah, I mean, the main foot control at the ankle moves the ball of the foot around, but the ball of the foot does not move the main control. And there's nothing we can do about that because this is a conventional rig, but that's just the way it is, right? However, what we definitely don't want is to be rotating this up like this, which is going to end up moving the actual ankle joints up once I hook that up. And then also have it move the toe, right? The toe needs to be independent. So we can actually drive the toe exactly the same way we drive the ball control. In fact, I can literally use duplicate special and duplicate it with input connections because they're basically the same thing, right? So this is ball control. This is toe control. This now becomes toe and it's really the same buffer for both of them, and you just need a different way to select them. They're both going to have the same pivot point, you just need to select them differently, right? So we're going to grab toe controls and shift its... Oh, haha! Yeah, I should have seen that coming. Does anyone notice, like, the silly mistake I made there? That's unfair. I shouldn't be like, do you want to say this in front of the class? No, the problem I made was I did this with input connections. So the inputs... This make NURB circle 2 thing, it's the same one. It's the same make NURB circle either way. So actually that's not very effective at all, right? Let me just delete that. I'm just gonna make a new one. There we go. Now, what we can do here to make sure that this ends up at an appropriate place, given that we're allowed to plug in whatever the hell we want, right, is that we can actually drive the position of the control, not the position of the position of the circle, not the position of the actual control. We're just talking about the offset of the shape, because the control should be back where the ball is. And, you know, one principle that we're going to be following here, which I think is very important, is never, ever, 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 ever move a pivot, right? All transforms just act as transforms, because pivots introduce a bunch of complexity, right? You no longer can you find out where your transform is just by multiplying matrices. You've got to consider these additional offsets. They have to happen in a particular order. It's a huge pain. So we don't want to have any. We're not going to like move this in forward and pull the pivot back. We're going to control the actual position of the shape. To be so that if we made this longer, the toe would be wherever it's supposed to be. So, let's see, we're going to be driving center X. Here we are going to have to do something that's a little bit different, but I think it'll be fine. Yeah, here's what we need to do. So we don't actually want to drive anything with a matrix, but we do want to get the results of the decomposed node for a matrix in space. So let's get rid of all that crap. We don't need it. But we do. And this will be okay, by the way, for us to not have to assign these to variables first, because the matrix in space function, which is going to add new nodes and change the selection on us, is not going to run until its arguments have already been evaluated. So this will actually be fine. It is a little frustrating that it does that. And one of the things that I have done in past projects, which again, maybe I should do it here too, is you can make something in Python. Often this is implemented with a decorator that essentially says, no, after this function runs, store what the selection was, and then restore it after the function runs, so that you won't get that sort of issue. And that would be useful, but I'm not going to do it right this second. So we've got matrix in space. We want to pass that to decompose node. I think that's what I called it. Decomposed matrix input. And then the result of this, I'm actually going to call this decomposed node, because I'm going to need to figure out what I want to hook up. So I'm just going to store that in a variable. I selected the wrong thing is what it is, actually. I needed to select inputs. There we go. So decomposed node is the decomposed matrix node that we can now plug into whatever we want. Note that I'm now doing all of this without ever actually using the node editor. And it certainly is true that the node editor can make things more visually clean or visually clear. Clean, not so much. Clear, yes, if you're not used to doing this. But I often find that doing stuff like this from the command line just has all of these benefits in terms of, honestly, not overwhelming you with a lot of visual complexity, actually, because while it is generally a thing, and this is also true to some degree with blueprints, although I do think that blueprints do a better job overall. But visual programming languages have this advantage of making things very visually clear, but then they have this disadvantage of making you pick through a lot of visual stuff to sort of get the information that you want. So it's a double-edged sword. And sometimes it's really useful, right? I'm not saying don't use the node editor, especially if you're not comfortable with doing things this way. Like, the node editor will work perfectly fine. But I am saying it is often worthwhile in my experience, right? If you can just do something from the command line and you know that it'll work and you know what you're trying to accomplish, then it's often faster to do it that way. Or at least less irritating. I mean, it sort of depends on how you look at it. Let's see. So I believe that output translate, for instance, if you happen to know that it's called output translate, right? X, I'm going to plug that into make NURB circle. I think S1 is actually here. Let's just check that. I think I have that selected now. Yeah, that's exactly what it is. Make NURB circle 3 dot center X. I think that'll do it. I possibly... I see what I did. Yes, that was very silly of me. Let's go back to this here. So see how I've gotten, like, you know, the ball and the ankle? Well, here I'm getting the space of the ball in the ankle space, which is actually a much longer distance. I completely got the wrong thing. I want the toe in the ball space. Oh, and also, it still thinks NURB circle 3 is what is selected, which obviously is not going to give us any useful answer. It doesn't have a toe. Is it maybe called something else? Oh, this is toe overshoot. Right. That makes sense. There we go. That's what I expected to see. Now we have, now as we extend the toe, this will always maintain the right distance, but the pivot point's actually back where it should be, right? All we're doing is actually changing the appearance of that control. Now, when in practice, the user can go replace these shapes with some other shapes, that's perfectly fine, right? You're allowed to, as the user, go make these shapes be whatever you want, but I'd like them to have sort of like a reasonable default arrangement, right? You know, something that will work. And if you want to go, like, replace them with whatever you want, go right ahead, you know? But it's not necessarily an obligation. All right, so these two can both pivot independently, which is exactly what we want to see. All right, what's next? Well, saving so we don't end up kicking ourselves later. I'm going to go make an IK handle. Then we're going to get into some stuff about pole vectors. Okay. It went and put the pole vector over here. We're going to do something else with that in a second. But in the meantime, we're going to take this IK handle and we are going to parent it to the ball, because of course we want it to do this. I mean, we don't want it to do that, but we'll get to that in a second. Now, the problem with this, of course, is that while the hierarchy and the arrangement of things here is appropriate, it's not responding to what the guides are doing right now, right? So I'm like doing this, and like this is gonna, this is obviously not right, right? And the reason for that is, just like everything else, the placement of this this IK handle has to be defined by the guides, and right now it's not. So here's where the uses of that, of putting these inputs all being world space, actually becomes really important to how easy it is to put this together. Because, watch what I can do here. If I just go back through my things here. Yeah, I don't need that. Yeah, probably that one. Here's what I can do. I can say I'm going to drive, I'm going to do the inputs, and then the target node is this IK handle, but I'm going to drive it off the, so here we did the ball in the space of the ankle. Now we're doing the ankle in the space of the ball. And we're allowed to do that in any direction we want. And it doesn't even have to be adjacent in the chain. I mean, I could do, and you know, the ball of the foot in the space of the knee if I wanted to, right? You know, it doesn't matter. It's all totally disconnected, and therefore I can do something like this, which should then, let's see if this actually worked. Yeah, it did. There we go. So what's going on here is that this IK handle, right? It needs to be parented to the ball control because we want it doing this, right? Excuse me. But the actual placement of that control, I mean, it would be very simple if it was just parented to the ankle control, but it's not, right? And it can't be. And that's exactly the kind of thing where if I simply parent it now, gets essentially baked into the structure of the rig, right? Somewhere now in this rig, actually in the transform values of that particular locator, it has values. And those values are essential to what the proportions of the rig are. And those values are probably correct. I mean, they are correct for this particular set of proportions, but if you change the proportions, they will be wrong. And so this is exactly where I feel that conventional auto rigging tends to fail, right? You've got all this data spread all over the place and it's all got to match up. And because we're being explicit about like every single time that the placement of a node depends on proportions in any way whatsoever, which is almost all the time, right? It must be driven off the inputs. This is not the case. All the data just flows right into the component, tells everything where to be, and you can literally do it in real time. You know, like everything is now hooked up properly. Now I've got it like this, and I can still use the ball of the foot, just as I had conceived of it, right? So one more thing we're going to need to do, though, is that because the contour IK handle in this case is not literally because it needs to be parented to something else, because like one way you could do this, and it is actually how I'm doing it for the arm, where you don't have like a reverse foot type situation, like that's not a thing, is that the contour, this control would actually be the contour IK handle. But because we're doing this reverse foot rig, that's not the case. And the contour IK handle has a whole bunch of stuff that we would like to, because you're not going to select this directly, right? It's going to be hidden. We would like to actually have that all be controllable from this control instead. Now this is the sort of thing that you certainly could do manually simply by basically creating each one of these controls and each one an attribute that matched and then hooking them up manually. I'm not going to do that, right? But also scripting that would be a little bit of a pain because we got to make sure that the input, the min and max are correct, because that matters in this case, and a variety of other things. So I'm going to do a really cheap trick. Duplicate. Now we've got an equivalent thing with this IK handle that's hooked up to like basically nothing, right? You know, it no longer drives anything. Because in Contour, unlike in Maya's IK handles, although I'm pretty sure this actually wouldn't be an issue for Maya's IK handles either, but it is certainly true that in Contour, IK handles are just transforms with some outputs. There's no concept of implicit control in Contour. We actually use the Maya node graph in ways that Maya doesn't when it comes to IK handles. And as a result, we can just duplicate this, and now all we have is a transform that happens to have all of these attributes hooked up properly, right? You know, I mean, I shouldn't say hooked up. They're not hooked up to anything. It's got all these attributes with their appropriate min and max values and default values and all the other things that they're supposed to have. And we're actually going to substitute this for that. So let me just do this. This is going to become our new foot control. And there's a couple of things that we are going to do to make that happen. One of which is that we're going to take the shape for the foot control and stick it under this one. Oh yeah, also unhide it, because that would be very useful otherwise. With a little incantation, because, I mean, you actually can do this for the UI, but we are saying that it should be relative, but also that we will actually parent shapes, which is not normally allowed. Or is it shape equals true? Perhaps it is shape. Yes, it is. Okay. So we can get rid of the locator at this time because, you know, probably not a big surprise to many people who've dealt with Maya, but, you know, might be actually to some people who might be more from the animator side of things. Locators are not, like, they have no, unlike IK handles or joints or a variety of other transform types in Maya, I mean, including some we've made ourselves, like including like our contour joints and stuff, which are their own type of thing. Locators in Maya actually aren't. They're just transform nodes with a locator shape under it. So, now that I have put the foot control shape under Contour IK Handle 2, I have a situation that is precisely identical to the situation that used to exist with the foot control. Now, all I need to do is to parent that, shapes, get rid of my foot control, and rename this one foot control. And now I have something precisely equivalent, except it has all of this stuff that I actually want to have. Now I've got to go hook that stuff up. Because obviously, if the user's moving it around right now, if you're doing your FK-IK switch from here, it's going to do nothing. It's not hooked up to the actual IK handle. So here's another kind of nice thing about this that we can do. Here I am going to use some scripting. And again, I do feel a little unsure about that sometimes, because I know that in a lot of cases people do find it confusing, or they don't find it very like it's not necessarily teaching people things that are actually actionable to them if they're not familiar with Python. But in this case, I do still feel like it's worth it, because it makes this process so much faster. Otherwise, you're just going to see me manually doing stuff for like kind of a long time, right? So I think I am going to go ahead and do that. And I apologize to anyone who would really prefer that I not do so. I understand where you're coming from, but I do think this is just going to take a long time if I don't. And this technique is really kind of useful too. Like, let's see what we want to do here. So what we want to do is we want to take all of these attributes on this node. We want to hook them up to the equivalent attribute on the other one, right? So our foot control now has all this stuff, and so does our IK handle. So the first thing I'm going to say is S1, again, gets the first item in our selection. The equivalent would be pa.selected, and then you index to get the first item in the selection. Same thing. And I'm going to say list adder, which should give me all the adders, but I'm specifically going to say that they are user defined. And let's see if that just lists the ones I want. It does. And so this is the difference between an attribute that is an inherent part of the node and is defined in the node's class. When the node itself is being created, and an attribute that is a user, an extra attribute, right? It's the sort of things that you see in the attribute editor under extra attributes, right? Attributes that are added by the user. In our case, we are making a lot of our attributes technically extra attributes, even though because our IK handles are in fact just transforms. So if we want extra attributes on there, it's a lot easier to just stick some attributes on it than it is to make a special transform type. Here's what I can do. I'm going to say foot control. Let's see this, that. So that's S1.listAdder. Those are the ones from the IK handle. Yep. S2 dot, same thing. And I'm going to use, so here's a bit of Python scripting that, especially if you come from a Mel background, would be really weird. It's not actually at all uncommon these days, though. I'm going to use something called zip. And I'm going to say for, let's see, handle adder, control adder in, and just to make sure I'm actually doing something useful here, I'm going to print some stuff. Yeah, right. I've been doing some stuff in Python 3 lately, so the fact, it just every time it throws you, the prints work differently. Just to make sure that I'm actually getting all the things I expected to get. These are the things I want to hook up to each other. They certainly are. And so what's going on here is this is just like a nice little way of saying, oh, I'm going to go through, I've got this list of attributes, but they're equivalent. And I'm going to stick them together into this sort of like list of tuples of like groups of these attributes that go together. And then I'm going to be able to destructure them by, which means basically assigning a variable to them, like sort of right then and there. I can do like two variables, and it will take my little package of two things that go together and turn each of them into a separate variable that I can then, do stuff with. It's much nicer than writing out some sort of script that does that longhand, and it's part of the reason why I do so much ad hoc Python, actually, because when you use techniques like this, doing stuff like this is pretty, it's not that hard. Whereas if I had to do something where I was like, oh, I need to go like, make two lists and then index into one of them with the index of the other, and I had to think about it more, it would be a lot less convenient to do stuff like this programmatically. So I'm just going to say handle adder. Actually,
Have you, by the way, Raf, I know you like list comprehensions.
mm-hmm.
Have you ever noted that list comprehensions can actually comprehend over more than one variable at a time? It's another way of writing this kind of stuff, right?
Indeed.
I'm just kind of curious about it. I know you like zip, and there's nothing really wrong with this. I personally, though, I find like doing a comprehension that has an X and Y out of these two things a little bit clearer. But
it could be, right? Like that's also a perfectly good way to do it. I'm just kind of used to zip, and it's clean and nice,
Sure.
But anyway, so I'm going to say, so here's one thing that I'm going to do here that's a little bit that I'm going to note, which is that the sort of the simple thing to do here, and it would probably be fine, but I don't want to do it, and I'll explain why in a moment, would be to say, well, I'm just going to take like my control adder, and I'm going to output it into so it would look like this. And I just tell it to go into the control, connect it to the handle adder, and then you basically have this structure where the control adder is puppeting the handle adder, which is then going to output its stuff to wherever it's going. That's perfectly fine. Like in this particular case, it probably wouldn't be an issue, but I don't really like it. And part of the reason why I don't like it is that it creates a situation in which data isn't going actually where you want it to go. It has to go to some other place first. And there's no real reason for it to do that. It's not like the handle needs those values to do anything. It's the IK solver that needs those values. So passing them through the handle first just complicates the graph. And, potentially, I mean, in reality, in this particular case, it probably doesn't matter much at all, right? But potentially, when you do a lot of stuff like this, could produce things that bottleneck parallel eval. So I don't really like doing that. And what I prefer instead to do is to say, well, what's the thing that the handle adder is actually outputting to? Which is pretty easy for us to find out. So, what this is an attribute, and what this outputs thing does is to get all of the things, and in this case, I know there's only one of them. I mean, I happen to know that in this case. Actually, do I know that in this case? You know what? I don't, and I shouldn't do this because this is not safe. This is what I should do. So here's what's going on. There might be multiple outputs. What this plugs equals true thing means, and the whole thing with Maya and plugs and attributes is actually super confusing, and it's very unfortunate. But for our purposes right now, this just means attributes. For the attribute, for each attribute that this handle adder is outputting to, I'm going to tell the control adder to output to that same output instead. So essentially, just instead of being, I'm going to puppet the handle adder, which is probably what I would have done at like an earlier time when I was rigging, right? Instead of doing that, I'm going to plug each of these things into the result of the output, right? So that was a bad way of saying it. I'm going to plug into all of the things that handle adder could be outputting to. And I am actually going to open up the node editor here, because otherwise I feel like this is maybe going to be confusing, right? I want to give a little bit of a better sense of what I mean by that. So in the case of here's our contour IK handle, we can say it's outputting to a bunch of stuff, right? And a whole bunch of these, like FK-IK switch, auto stretch, etc., they're outputting to various things. And indeed, I think I was correct that some of them output more than one thing. So it was important for me to recognize that, because otherwise this would have broken everything, right? And then the let's see, what do we have here? Right, the actual foot control, and it has equivalent attributes that are not, right? It's got like your IK-FK switch and what have you that are not outputting to all these things. And by starting with the handle and then selecting the foot control and running this code, what should happen, actually I'll just save first, It's never a bad idea. Oh, I already did. Yeah, I screwed that one up because I probably selected them in the wrong order, and I did. All right. No, I didn't select them in the order. 1 second. So here's the S1 and S2, the handle adder and control adder. Yeah, oh right, yeah, what was I thinking? I just typed handle adder without thinking about it. That is, of course, not going to work. Oh, right. Yes, well, that is a little bit obnoxious. I mean, it's supposed to be locked, but obviously means we need to do something slightly more complex. I'm just going to undo that real quick in case it actually did anything. I think it didn't actually. And we will need to say this. If adder dot, I think it is locked. Oh, I'm going to do something real dumb here. Yeah, here's what I'm going to say. I'm going to check and see if the adder is locked. And then I'm going to say if is... Actually, I don't even need to do that. I can just unlock the adder no matter what, and then only lock it again if it actually previously was locked. So I can do this. And then, after it connects them, I can say if is locked, I will say adder lock, so that I lock it again when I'm done. And there we go. Now it is basically all of these places, not all of them, because I deliberately didn't want it to do that when it comes to the matrices and the rotation and stuff like that, because we're still driving that off the IK handle. But I wanted the foot control to control all of this other stuff. So instead of looping it like through here and then over to the rest of the graph, I can just directly have it go control anything else I want in the rest of the graph. And I do think that this example here of the like is locked, unlocked stuff is an example of where doing things like this ends up just netting you enormous gains, actually. Because if you were doing this by hand, and then you encounter this issue, you'd have to manually like unlock stuff and like manually figure out a bunch of... It would just be really painful. Whereas here, there's like a pretty clear way of just doing this, and it didn't really take that long. It is really, really, really beneficial, which is why I resist doing it all by hand so much. All right, so at this point, we should have the ability to, there we go. We can turn off the FKIK switch. We can also control things like auto stretch. Yep, there we go. It is doing what it's supposed to do. All right. So, what's next? And as we can see, this is actually behaving also as it should, because of the fact that the IK handle, which is over here, is still, the thing that's controlling the matrices and rotation values being plugged into the IK solver. So even though we are controlling a bunch of stuff that automatically gets stuck on the IK handle, like all of this, first bone stuff, off a different node now, the actual main behavior of the IK handle will still work as one would expect. So, let's see, what's next? So obviously I do need to deal with this, right? This behavior here, obviously not correct. But I think actually the next thing I want to deal with is actually the IK handle. Because I think, honestly, just because I think that's a really interesting problem. And I'm thinking that to do that, I am going to go over the code that I have that I cobbled together to do that. Because doing it manually would be really painful and time consuming. But I still want to try to give you as comprehensible an idea of what's going on here as I can. And last session, we talked a lot about rotate planes, for instance. And we talked a lot about, and that was in the context of making sure that when we moved these things around, and you'll note that they diverge, and the reason why is because we're not controlling the IK, the pole vector, is that when we move these things around, we need to make sure that they're all oriented onto a plane. This is basically the same concept as a rotate plane IK solver, right? Everything works in this rotate plane. And that's certainly, and what's happening when you're changing this pole vector, actually, this is how rotate plane IK works, right? Is that essentially you're using the point at the beginning of your IK chain, the point in the middle, I guess you could say, I mean the pole vector in this case, right? And the point at the end, and you're using the vector. Well, I mean, actually, there's a number of ways that you could sort of consider those vectors running, but the real idea is this is a triangle, right? We've got 3 points, and it forms a triangle, and all triangles in 3D space form planes. Then when you actually calculate the IK, you're essentially doing it in 2D, which actually makes it a much simpler problem. I mean, a vastly simpler problem. I mean, before people really settled on rotate plane IK as the primary method of doing IK, there were, there still are. I mean, there's still circumstances where you do this, but were all of these very much more complicated solvers that did like iterative approaches of various kinds, and required you to like set up various kinds of limits so that it could try to choose the correct IK solve out of the various possibilities. And they were all much, much more complex. The nice thing about rotate plane IK is that it's really, really, really simple. I actually wrote, I think this is something I actually want to go into on a later stream. I actually wrote one by accident. I was writing something for the ephemeral system that was supposed to maintain proportions on an arm. And after I had written it, I realized it was actually an IK handle. I don't know if I told this story last time or not. That is something I kind of want to talk about that method at some point because I find it amusing that happened. But regardless, what we need to do here is to basically do that same kind of math to figure out where should the pole vector go in response to the movement of the guides, in response to its inputs, right? And as it happens, I already had a function that does that exact thing. Let's see, pole vector transformation. So here's what's going on in the pole vector transformation. It might not be very obvious, so I'm going to try to get to the sort of the point of how it works, right? Without necessarily getting bogged down in the details of like how does this actually function. But I have at least grouped it into some little mini like sub functions that you can I can sort of explain what they do maybe, or start off with that. And one is the method of figuring out what that rotate plane is all based on this concept of cross products. So this is a linear algebra thing, and I don't really want to explain too much about it, but I will simply say that essentially what it does is that you have two vectors, like whatever, there's like a vector here and a vector there, and the cross product is the vector that is orthogonal to both of them. So if these two vectors form a plane, then the cross product is the normal to that plane. And so if you want to know what the plane is, you can basically say, well, I have two vectors, right? The two sides of my triangle, and whatever is going to be normal to that is going to be the vector that's like pointing straight out of the plane. And if you then do another cross product to, essentially give yourself three orthogonal vectors, because then you can do a cross product between like this one and that one, then you end up with a matrix, right? Which is the space of your rotate plane. So essentially what this is doing is, it's able to, the whole vector difference thing that it's doing, like essentially most of the reason why this is complex, because if you were to write this out as like, like in a programming language, you're just writing it out as a function in Python, you would, it would actually be much less complex than this, which sort of encapsulates some of the issues with auto-rigging, actually. But a lot of this is, I'm basically doing all this sort of stuff that I did here, but to do a few things that are really specific to this function. If I can't just normalize the vector, I have to make an actual vector product node to do it and hook up everything properly. I can't just do a cross product, I also need to use a vector product node, etc., right? Vector difference, same deal, right? I need to basically make the nodes to do all of this stuff. And then what I was just describing about the two cross products, right? You've got like, this one, two vectors, right? And this would be, in this case, it's like the vector between the hip and the ankle, and the vector between the hip and the knee. Those are your two vectors that define your rotate plane. I'm saying I use two cross products. Like, again, I don't really want to get bogged down into why it actually works in this particular way, but you're using two cross products to turn that into an actual space that you can use. And then we figure out a distance away from the knee that the IK handle should be in, right? Because you could have all kinds of proportions. And if you have your character's a mouse, then the distance away that the pole vector is by default is going to be totally different than if the person's like King Kong, right? They need to be two completely different things. So you get the distance. Let's see, what am I doing here to figure that out? I think I'm actually using the distance between the length of some of these vectors to sort of figure out an appropriate distance. And finally, what we're essentially doing here is where do we actually do sorry, I'm trying to figure out like how this actually runs. It outputs into this multiply. See, I should have named some of the stuff better in my code. I see what's going on here. I'm making a vector that's getting added to the thing's position. So I'm basically what I'm basically doing here is I'm saying get a position, right? And I think I may even be starting with the position of the knee in this case. Although again, I'm not. Yeah, see, node 2 world output translate. Yeah, that is node 2 in this case represents the knee. It could be it could be a no, I called it node 2 because it could also be an elbow, right? And then the pole vector node translate that's getting driven by this adder. The whole deal with the adder is that I need ultimately the output of all of this is actually just one vector that points away from the knee or elbow. And I just need to make sure that it's the correct length and that then it starts from the position of the elbow, and that gives me my position for the pole vector. And I don't really care that much about rotation, so I'm just giving it the rotation of the elbow or knee. So a little bit complicated, right? But conceptually, here's what's happening. First, it is using some cross products to figure out what the angle, like in this, what's the plane formed by the in this case hip, knee, and ankle. It figures out a vector that, by doing that is normal to that plane. Then it figures out a vector that is basically on that plane but pointing away from the second control here. And then it basically has the position for that thing, so it goes and takes the position of the middle joint, adds that vector that points in an appropriate direction, and then that gives you your position that your pole vector should have. So if I have been correct in my supposition about how this thing I wrote a long time ago works, this should work if I do like this. So let's actually grab the buffer in this case. And what does it want as inputs? It wants node 1, node 2, node 3, and pole vector node. So in this case, I'm actually going to have to modify this. I really should have looked at this before we started this stream. And here's the reason why. This, just as some of the other things that we looked at in the past in regards to the componentized stuff, this assumes that these are actually transforms in the scene. And in this case, they are not. Right? We are not actually driving any transforms in the scene. We are taking in inputs in the forms of matrices. So this has to be actually has to be rather different. It has to be like matrix 1, or actually matrix input 1. And here, where we have node 1 world, node 3 world, these actually basically are that. Like, we're already getting world space matrices being added here. So we don't need to like do any of this decomposing of matrix inputs in order to get the world. Although this assumes that we are yes, because it wants to get the translation. So all we need to do here is to change this so that instead of decomposing the node.world matrix, it's actually decomposing just the matrix input for matrix input in, what did we have here again? Matrix input 1, 2, 3. Now, I do want to sort of throw it out there. As happened previously, I was not as well prepared as I ought to have been. All the stuff I've been describing about how the cross products and the IK handle stuff works could be really, really, really confusing. So I do want to sort of throw it out there. Does anybody have any like questions? Does anyone want to be like, what the hell are you talking about? Because I would be happy to clarify anything. Well, I will keep my eye on the chat.
Yeah, I'll keep an eye on it too.
All right, so I think this is probably going to work. Let's find out if the surgery I did to this function is actually going to do what I think it's going to do. So what I want is, here's the pole vector node. That's actually going to be that. So here's what I need. I need that. I need the pole vector node. And I'm going to say, shift this off screen again, I'm sorry to say. Oh yeah, I got to reload it too.
You know, it occurs to me, Raph, that it might be worthwhile at some point putting some of this library code that you have for helping with this on GitHub.
Oh, I think it absolutely would. I mean, the reason why I haven't done that, and for a lot of the little functions that I use, is exactly what we're seeing right now, which is to say, this isn't code that I've been like, oh, this is going to be like nicely commented and it have like, you know, I'm totally sure it works and whatever, because it's all stuff where like, oh, if something goes wrong, I'll just fix it, right?
Sure, but that's the nature of open source stuff. You know,
I guess that's true.
We could go over it a little bit and just sort of like check it before you put it up, but it might be kind of helpful, right? If you're demonstrating a technique and you're using this library code, you could say,
you'd be like, oh, you can just use it yourself. Yeah, absolutely. I think that would be really helpful. I have actually thought, this actually brings up something that I have been meaning to get back to, and I do want to really soon, which is I actually did a little bit of work to clean up my script that mirrors the blend shape mirroring, and I actually think I could put it up on GitHub now.
Okay, so, yeah, we kind of did promise people that we would do that.
We really did, and it took a little bit for me to, Yeah,
it kind of fell by the wayside. But
it kind of did, but it's actually a really important thing because Maya doesn't provide you any way of doing that yourself. So, so we really should put that up, and I think my new version of it is much cleaner and less prone to just like weirdness than the earlier version, which was a complete hack, right?
Right.
I mean it's still a hack, but
yeah, I'm kind of curious about that. Do you think that there is a good reason that we shouldn't just maybe add that as like a little utility menu option in Contour, or is it just like too specific to things?
Right? No, I actually am going to say we absolutely could. Now we would need to add some like error checking and stuff, you know, like there would be some work involved in that, but I think that would be a pretty reasonable thing to add, and I think maybe we should. Because honestly,
I mean, it seems like a kind of an important and useful thing to be able to do. It comes up a lot with Contour, and you know, I mean, we could throw it on GitHub, obviously, but it'd be a lot easier if it were just a menu item, right?
Yeah, we absolutely could. Like obviously, you know, in that case, we really do have to, you know, test it thoroughly and stuff.
Yeah, we'd have to work on it a little bit. Yeah. But I mean, that's always the case with putting stuff in the actual software. Yeah, we should probably consider that. Okay.
Yep. Anyway, pole vector transformation. We're going to say s1.inputs no, sorry, what am I saying? S1 is inputs. We're going to do S1 dot, right, we need the hip to start with. Then we need the knee. Then we need the ankle. And finally, we need the pole vector node, which is S2. Now, I will note one thing here, which I think is pretty relevant. So remember how I headed off an issue earlier on by being like, oh no, it was going to screw around with the selection? That was because I was nesting things. And that meant that one thing was going to get evaluated first and change the selection, and then other things would get the wrong answer, right? Wrong selection. In this case, it's actually fine, because all of these things are essentially at the same level. Nothing's being evaluated other than just like getting these various things before being passed into the function. I just wanted to note that that's the difference. And I think that worked. Occasionally things do. Yeah, there we go. That's exactly what I wanted to see. All right, we have a working pole vector at this point. We are going to have to do some more space switching for that, of course, because pole vectors are one of the things you end up space switching the most, right? I actually hate pole vectors, right? Like the idea that there's something out in the middle of nowhere that affects your knee, I hate that. And the solution I came up with for the setup machine, which is to have this kind of arrow, which is actually the pole vectors just at the end of the arrow, is only sort of marginally better. There's not a great answer to this. I mean, there is actually, but not within the context of conventional rigging, because you need like a feedback loop basically during your interaction to be able to do something. This is actually something I want to implement soon for the ephemeral system. Grab the knee, and with IK on, constrained to that circular arc that you'd be able to do while maintaining proportions. This is what I was, talking about before, is that you kind of want to be able to be like, oh, I can try to move it anywhere, but it's going. I can get rid of that buffer. That's not actually useful. I'm going to call it pole vect control, and this one is pole vect buff. All right. So we've got the pole vector working properly, so we can now arrange this and then use this as, continue to use this as we want. Of course, it'll do that because pole vectors, but what are you going to do? Now, here's the remaining thing I think we're going to do today. This is all fine. And this is all fine. Well, I mean, this isn't, but, But it is very easy, like if I push this past, it'll go like that. And generally speaking, that's not what you want, right? I mean, this issue kind of goes away if you turn on auto stretch. Because if you turn on auto stretch, then everything actually works out quite nicely, right? It's always going to stretch to fit. And then similarly, if we're rotating the ball of the foot, you don't see weirdness, right? Because the stretching takes care of it. But people don't necessarily always want to have auto stretch on. I mean, I kind of do, but not everybody does, right? And as a result, you're going to get situations like this. And what this is the IK handle reaching its extents, right? It can't make things any longer. And so what it does is, kind of weird. Like, it can't really do anything about that. And the fact of the matter is, we actually can't either, right? That is to say, if it can't stretch, then it can't reach the IK handle, then it's going to do that. But what we definitely don't want is the toe flying up in the air like that when that happens, right? So, here's how we're going to do this. We're going to use a aim handle. Let's make a contour aim handle. We're going to do one for this toe as well. And we are going to take the aim handle, and in this case we can just parent it because it doesn't, it's just going to be at the center of this control. It doesn't need any deviation from that, so we don't need to hook it up to something coming in from the inputs. And we parent this one to this. We get rid of these buffers because we don't need them. And now, yeah, this is what we would expect to see. And so basically that means it's going to try to reach, right? Now actually, oh, that's right. I made this aim handle stretchy. So it's going to stretch to reach, which isn't necessarily the behavior that you want. And so that's actually a something we may need to do something a little bit manually about. I'm going to get to that in a second, I think. There's a couple of other things I want to do first. So thing number one, we want to make sure that these all switch at the same time. So, here's one issue. Like, let's say I FKIK switch this, right? I'm going to switch that off. In which case, they don't have circles yet, but, I should be able to just rotate the bones. But, I'm sorry to say, it only switched off the IK handle. It did not switch off the other thing. It did not switch off the aim. So, that should be easy enough for us to fix. We need to grab the aim handles. Here's our aim controls. Probably shouldn't be named that, but I'm not going to worry about it right this second. And they have this blend value. So we're going to do the exact same thing we did before. We don't want to control the aim handle with the foot controls FKIK switch. Because what you could do is you could just take the foot control FKIK switch and pipe it right into the blend. We don't want to do that. We want to pipe it into where the blend's going. Because otherwise, you just end up with extra connections in your graph that serve no purpose. And I don't like that. It's not going to be much of a performance hit in this case. It's not really going to matter that much, but I still don't like it. It's unclean. I'll do it all the time anyway when I'm doing sort of like ad hoc rigging, and I'm like, yeah, whatever. But in the case of this, which is something that is meant to be this system that's going to be used to generate lots and lots of rigs, I'd rather be a little more rigorous about this. So I'm going to do this one manually, though, because there's a lot less of it, and it'll make things a little more clear. Because we can take a look real directly here at where blend goes. And blend primarily goes... Actually, it may only go to one place. I think that may actually be the case. Is that the case? That can't be right. Because it's got to affect... oh, no, it doesn't affect rotation. That's right. That's a separate thing. So, no, this is actually quite correct. It only goes into one place, which makes it super easy. See, where's blend going to here? And see, this right here, this is why I often do things by command line, right? Blueprints are better about it. Like, if this was a blueprint, there's a decent chance there'd be, like, a bunch of this stuff grouped together into, like, some sort of struct or something that would get passed along instead, and it would just be a cleaner graph. Or you might not, depending on the circumstances. Regardless, here's what we can do. Yeah, this will be pretty simple. Just gonna grab this. We are going to take the FKIK switch. We're going to plug that into override blend. And it's locked. See, here's what I didn't want to do manually before, right? But I'll do it in this case, right? Because there's only two of them. It doesn't matter that much. Plug it into override blend. And then lock it again. The reason why we lock them, it's actually pretty important, is that otherwise, when you key these things, you could conceivably be keying those too, and that would end up creating a lot of bad stuff. Like, those are supposed to have incoming connections. They are not supposed to get keyed. All right, here's the other one. What was I saying? That should not be it. Here we go. Plug that into blend, and then lock it. All right. So what should be happening now is that when I turn the FKIK switch off and rotate like one of the joints, come on, there we go. It should, no, that didn't work. Right. I knew that couldn't be right. Right. I'm also not controlling the outputs into the joints themselves. Right. The joints have outputs coming into their override rotation, and this override blend also needs to be controlled. So let's go do that. We can actually just grab these two and bring them right in. Where are they? Ah, yes. See, I was wrong about blend only affecting certain things because the graph was confusing looking. Undo. And that is kind of why I don't really like using the node editor. All right, so override blend. Override blend. Let's lock this. All right. Now I expect that it will work. And indeed, it does. Yeah, there we go. I'm sure I've talked about how awesome override blend is in the past, but it's really awesome. It makes things much easier. All right, there we go. And this should still, yep, and it does. Obviously, it stretches, which isn't what we want when auto stretch is not on, and so dealing with that is going to be our next thing, which is that we want to modulate basically the input coming into that override blend for stretching by, in addition to what we're already doing, whether auto stretch is on or off. And that I'm going to kind of do manually because it's just two things and they're less, you know, like this probably isn't worth writing code for this specific thing. So let's see, what do we have here? Right. Here's going into the override blend. So what we're going to need to do is basically what we want to say is, this override blend is going to only be one, i.e. the stretch is being driven only if if it is both true that the FKIK switch is on and that auto stretch is on, which is actually pretty simple. I mean, it's basically just a multiply node. I will use a double linear. Why, you may ask, is there not a divide double linear? I would also like to know the answer to that question. I'm tired of using multiply divide for that. There is a mult double linear, though. And then, right, we need to take auto stretch and plug it into input 2. So if either one of these values is 0, then the answer will be 0, right? And if you only get 1 if they're both 1, which is exactly what we want in this case. And so here's our two bones, and we're going to need to unlock their override blend again. And then we're going to lock it again. All right, let's see if this works. Yep. So in the event that auto stretch is not on, they do not stretch. But in the event that it is on, they do, which you can see because if you were to pull it like this, it will in fact stretch. Although to be fair, is this going to be like a translatable thing in the actual rig? I'm not actually totally sure. But it's not a terrible idea to make that a possibility, you know? We can decide to lock that down or not. Personally, I don't really want to, but at the same time, it could be kind of confusing to people. All right, so here we have our basic reverse foot. With pole vector. And this is all working fully, actually. We now have a usable reverse foot rig. Now, it is lacking a few of the things that people sometimes put into reverse foot rigs. And, in fact, I'm probably not going to do them. Here are a couple of the things people see, people often put in reverse foot rigs, which I am not going to do. Foot rolls. I kind of ranted about that a little bit last time, but foot rolls are not good. And the reason why I think foot rolls are not good is that they are essentially canned bits of animation that you're saying you can sort of cycle through. For people who may or may not be familiar with that term, although it's pretty common, so most people probably are, but people do things a lot of different ways, so who knows? That essentially has this thing where you're using your reverse foot rig, and it's got a bunch of other nodes in there that, usually using driven keys, have like an attribute, and as this attribute, as you increase the attribute, it cycles through a foot plant, like heel strike, foot on the ground, toe up, foot off sort of animation, right? So that you're walking and you can presumably be like, I'm just going to cycle through the thing that the character is doing when they walk. And the problem with this is that it assumes that there is one thing your character is supposed to be doing when they walk. And in my view, in practice, like, I have found this to never, ever, ever be true, right? Characters walk all kinds of different ways. Characters have different walks under different, depending on how they feel, right? Depending on what they're doing. Like, steps are not identical, right? You can make a walk cycle that you're going to use in specific cases, sure. But that's a cycle. That's kind of a different case, right? Building canned animation directly into your rig is something that I think is not beneficial, right? It's something that tends to funnel your character's performance into a very specific place that may or may not be right for whatever it is you're actually trying to do. And having presets of a sort is actually quite nice. I mean, I feel this way about facial rigs too, right? I don't like facial rigs that have like very specific poses sort of built into the structure of the rig. But I do like having pose libraries. Pose libraries are great.
It's kind of framework versus library.
That's exactly what it is. And
so
if you want,
the framework is always with you. You can't get out of the framework.
You can't get rid of it, right? Now, if you want to have like a canned walk animation that gets used in some circumstances, that's perfectly fine. We have them. They're called walk cycles, right? Like, we don't need to bake anything into the rig to make that true. All baking stuff into the rig does is actually kind of get in your way. And similarly, one of the things that you often see people do with foot rigs is to have these like special pivots that are like in various places. So you'll have a pivot at the end of the toe, and you'll have a pivot like sometimes at different edges of the foot. So like if you think of this as being the foot planted down, you'll have a pivot here and a pivot here, so you can rock the foot back and forth. And again, my experience is that I find this not to be beneficial. And the reason why I find it not to be beneficial isn't because it's canned in the same sense, because it's not. Like, that's not like a piece of canned animation, but because you really cannot account for all of the places your character's foot ends up having to pivot from, depending on what they're doing. And characters could be doing all kinds of stuff. They could be dancing. They could be doing martial arts. You don't know what your character is going to be called on to do. All of those things presuppose a certain set of assumptions about what your character does. And to some degree, that's actually unavoidable, right? To some degree, you do kind of have to make some assumptions. The very fact that we're doing a reverse foot rig does make some assumptions, right? But I want to make as few as possible. And I think that eyeballing stuff like that, ultimately, because of the fact that you honestly cannot actually know your character's foot does so many different things, right? Is that it ultimately just gets in the way. So I that's less like openly evil than foot rolls, right? I'm, if it was something people really, really wanted, like I could be like, okay, maybe we can add that. Like, it's not like I necessarily need to like say, no, this can never happen, right? But at least for the first iteration of this, I really don't want to add that. It adds complexity, and I don't think it's actually that beneficial to animators. I'm quite certain that animators, probably plenty of animators disagree with me about that. So I'm saying, like, yeah, I mean, we can be flexible about it, but at least for now, I'm not going to add those features.
And to digress a little bit, this is a little bit of the motivation behind the ephemeral system, right?
Yes.
Right, which is like to be able to do things like that without actually having to lock them into the rig.
Exactly, without having to. So, as an example, I mean, this is something that I brought up, like just before. But like, if this was an ephemeral rig, if I rotated the ball back, the ankle control would go with it, and then I'd be able to control the ankle control from here. Obviously, cannot do that in a conventional rig. That's not going to happen, right? And similarly, you can sort of see that, an example of that in the ephemeral animation test that, stream that we did, a few months ago with that box, right? Where you can have a pivot at each corner if you want to. You pivots all over the place. It doesn't matter, right? And that's the kind of thing that I think is actually really beneficial in this case, right? You know, if you want to have a bunch of pivots that are sort of there, but they don't imply anything about the structure of what you're doing. Because the problem with with adding these to a conventional rig, like just having like a whole bunch of different pivots, is that those different pivots have an order, right? You've got a hierarchy. The hierarchy has some kind of structure. It means some pivot's going to take precedence over some other pivot. And that ends up adding that cognitive load, right? Like the thing, if you're like, oh, I want to do this with my foot, right? I want to move the character's foot around, like however. But I use this pivot. Now the other pivot is no longer in a useful place for me to do that with. So I have to think about doing it in a slightly different way. And it just becomes this just like constant, it's a constant extra set of things running in the back of your head that are totally irrelevant. I know I'm ranting about this now, but they're totally irrelevant to like how does my character feel? Like what, you know, do the physics feel good when the character like pushes off the ground when they jump? Does like, you know, like is this an interesting pose? Like all of the things that we actually care about in animation, none of which have anything to do with like where's my pivots. So that's kind of why I'm keeping this simpler, right? And like I said, the pivots at the edge of the foot, that's a little bit of a different case. You could make an argument that that's actually kind of beneficial. Never gonna add foot roll. I refuse, right? So this now we have like the basics, right? Like we've got a reverse foot rig. We have FK2. I mean, they're hard to select right now because they're just the joints, but you know, you could select the joints and use them as FK. We have an FK-IK switch. What we are currently lacking, the last thing that we kind of have to do to this foot to make it like a viable rig that we can start adding to our body plan, is we got to do the space switching. And that's something I think I'm going to leave for next time because well, you know, because it's 6:30 and you know we've done about an hour and a half, and I think that's as much as I want to do right now. Probably won't go terribly slowly, given that again there's code here that I can use for that purpose. You know, I do feel a little like this might be more confusing to some people, but at the same time it's just going to take so long if we have to do it by hand. And I did a little bit explain some of how we do that with the componentized rigs in an earlier stream, but I don't know how much impact that makes without like a clear visual in like you can see it working, you know. So we will do that and we'll add it to a body plan and do a little cleanup, right? Because like right now, like, you know, things are named weird, the hierarchy's all over the place, you know, it needs to be cleaned up into sort of more of a packaged up thing. Once we do that, we have actually made ourselves a light component. I do again want to note, you know, part of this is because Contour does a lot of the work for you. Like I didn't need to implement Stretchy IK. That's just a thing the Contour IK handle already does, right? It doesn't do reverse feet per se. And the reason for that is that that's kind of a, like that's not something a specific node does, right? It's a particular arrangement of nodes. You could make a node in a system probably different than Maya that let nodes include perhaps multiple transforms. That would be like a reverse foot, or a better way to say that perhaps is one of the ways to handle this, and maybe it would have been if I was doing conventional rigging, it would have been the thing to do, would be to have the reverse foot just by itself be its own component with its own inputs and outputs. That's certainly one way you'd do that. And maybe you'd do the IK as another component, and you'd make the foot out of the you know, like you'd bring in those two components as subcomponents of the foot, of the leg, right? And the reason to do that would be so that you can figure out your Stretchy IK and reuse it, figure out your reverse foot and reuse it, like figure out any of this other stuff, you know, with Stretchy, whatever. But Contour already does all that stuff, so we don't really need to worry about it that much, and we don't need subcomponents. And that's an enormous reason why this hasn't taken very long. And another reason is that, you know, I'm deliberately not doing some of the things that people do that are a bit more complex with reverse foot rigs for like all the reasons I just stated, right? That's also part of it. But a big part of the reason why it didn't take very long to come up with an almost fully viable, almost fully featured, you know, foot rig is that component, you know, the component structure of things, right? The driving all of this stuff off inputs in an explicit way ends up radically simplifying what you need to do to make your rig repeatable, right? And this is a point I've hit like many, many, many times. And like, I'm kind of belaboring the point at this point, probably, right? But it really makes a huge difference, right? All of those things together make a huge difference. The amount of time that can go into authoring like a full featured conventional auto rigged leg rig is, well, you certainly wouldn't have seen me do that in a couple of streams while making things slow by explaining stuff all the time and going on rants, right? There is, and this sort of goes back to the stuff I was saying right at the beginning about like simplicity, right? Well, actually, I should say about actually simplicity is the wrong term. It leads to simplicity, but like good structures for things and how much you can understand about that from understanding a lot of the work that's gone into like computer science and programming technique, right? And how radically that can sometimes simplify things, how that can lead to, I mean, or not, right? Like obviously, one is not guaranteed a good result because one uses a particular set of techniques, right? That's not how that works. You always have to judge in the moment what's right. And I think that's an important point to make because it does get lost a lot, right? Like,
I think that's a tremendously important point.
Yeah.
Right?
Like there's no magical
procedure. There's no like magic incantation that makes sure that you're doing the right thing. You still have to do the right thing.
Yeah, exactly. And it's like that's one thing I do want to be careful of because I am very much in favor of a very specific type of workflow that I think is really beneficial. One of the things that I've been thinking a lot about in terms of the ephemeral system, we've been talking about this not over the last few months, right? Is that really though the point of the ephemeral system, I know I'm getting a little off topic here, but I do want to say this, isn't to impose a particular workflow on people. There's a workflow with it that I think is highly desirable and beneficial and that I think other people will gain a lot from, right? However, if you wanted to do like a hips out approach and there was some scenario where that was actually the right thing, and there are some where it is, and I say that as someone who's like really opposed to that under most circumstances, but there are circumstances where it's actually the right thing to do, and the ephemeral system should not prevent you from doing that if it actually is the right thing, right? Like, in theory, it doesn't have to. I mean, this implementation has a hard time with it because of the struggle of getting ephemeral behavior into Maya, but in theory, it shouldn't, right?
This is something that I've done a lot of thinking about, and I think it's a really important point, which is that judgment is always important, and there's no set of procedures that you can follow that can replace judgment.
Yeah.
Right? And people as programmers are always looking for them, right? Especially people who employ programmers would like to treat them interchangeably, right? It's
Sure.
just like, well, if you follow this checklist of things, then you'll be writing great code, right? And it doesn't actually work that way.
Yep, and it's actually, to some degree, this ties into like sort of the stuff we were talking about earlier with the foot roll, right? And I should say again, like I'm coming at this from a particular point of view, right? I'm coming at this from the point of view of someone who wants to really get up to their elbows in authoring like character animation, right? A lot of the places where people use foot rolls are like television animation and stuff. Where now, of course, my view is, well, okay, but that's not where you should be making your compromises. Like, there's other compromises you could be making instead, right? But nevertheless, it's understandable that people make compromises under those circumstances, right? Even if it would, like, actually make things harder for you in the long run, if you were trying to actually make something really good, you're kind of not under those circumstances. You're working so fast that you're just going to cut corners everywhere. Now, my contention would be actually foot roll isn't actually the right corner to cut. Because one of the first things you'll get much better. I mean, like I really believe this. I even believe this with conventional rigging. If you cut interpolation, depending on your style, right? Because some styles in a conventional context that just will never be viable for, right? But depending on your style, if you cut interpolation, you will actually gain more than that than trying to like. That's a better place to cut your stuff than foot roll is, right? In the sense of like the work, right? The work of polish that you don't want to be doing because you're doing TV animation, that'll gain you better benefits than using a foot roll. But hardly anybody agrees with me about that. And indeed, in the context of conventional rigging, that's often just not going to be viable. And so I think that's related though, because it is in a sense the idea that, and a lot of animation technique comes from this, like a lot of the methodology of like the old, I mean, a lot of the things I've struggled against in my career, and so I do have to be careful that I don't make a new dogma, right? But things like, you know, yeah, I mean, you have the hips out method, and then you've also got the you know, poses, but then you spline them and do offsets method. And part of the thing, especially that one actually, is that it's kind of an algorithm, right? It's this idea of like, here's the specific steps, and if you follow these steps, you'll be able to make good animation. And this has never ever actually worked. And one of the things that I'm trying to get out of the interpolation list, we're not actually using the term interpolation list so much anymore, because really there is interpolation involved. It's actually not really quite right. But we use the term dense animation data editing, right? Part of what I hope to get out of that is the idea that because it doesn't presuppose what you can do, like there's not a structure baked into the shot, right? Like you didn't put keyframes in any particular place on any particular things using any particular modes, like there's no switching, you know, etc. That it will free people to use the methodologies that work in context and be able to more easily avoid that sort of like, this is the procedure that I'm going to use. To be able to not have to do something in a really specific order. And like splining, for instance, is horrific in this regard, right? So you're like, oh, well, you know, I've splined, now there's no returning, right? I mean, there is, you could bake it or whatever, but like, you know, then you're destroying what you hope to get out of it. I don't want situations in which a procedure, an approach has to be done in a specific order, right? Has to be done in a specific way in order to keep your approach viable. And that's a really big and a rant that is not particularly germane to the thing that we were showing in this stream. But I do think like this whole set of ideas, like they're all interrelated, right? You know, I don't want foot roll for a lot of the same reasons why I don't want interpolation, right? I don't want assumptions. I don't want the idea that decisions made early on become difficult or in some cases impossible to reverse.
Right. And I think the thing is, I can sort of envision a system that would layer something like foot roll, perhaps in a controllable way, onto sort of existing animation, right?
Sure.
But it would be a choice that you would be making at that point.
Well,
right?
and oh, sorry, I didn't.
No, go on.
And indeed, in some ways, that's kind of how foot roll works, right? That is to say, it is additive, because it really couldn't work any other way, right? It doesn't actually take control of the keys of your foot. However, the problem is you get the same problem.
But it's always there.
But it's always there, and the problem is you get all the other issues you get with additive anything, right? Which is that now you've got to counter it if you don't like what it's doing and it's ugly, right? Right. Yeah, it's always there. Now,
I mean, I'm talking about something else. I really can see the potential for systems that are assistants, right?
Right.
That you can use to kind of say, well, I have this animation and there's this thing that's usually like this. And I'd like to add something like this and I'd like to parameterize it and adjust it while it's happening, right? Because that kind of thing does come up and it comes up a lot and you probably don't want it to always be exactly the same. But I could see an assistant being useful for that kind of thing.
Well, it would be. What it is if you had like an ephemeral foot roll, then all it would be doing would be creating some animation data for you, right? And this
that's
kind
what
of,
I mean.
Yeah, exactly.
I mean. Something that is adding it as animation, not as something that's part of the rig.
Right, exactly. It's like it creates something, and this kind of goes back to this whole thing of dense animation data being a very relevant way of thinking about like, how are we going to deal with the idea that, you know, and I have mixed feelings about this, but like it's coming and it's probably a good thing under most circumstances, right? Like we're going to have potentially ML-based ways of assisting us in animating, like, and that's going to be a beneficial thing, right? It's also going to have, like, I have mixed feelings about it, but it's going to be a beneficial thing in a lot of cases, right? And that is incredibly hard to figure out how to fit that into the concepts of keyframes and animation layers and the hierarchy as we know it, right? And the idea of something that can sort of assist you in some ways, like, oh, well, we kind of do have this sort of canned thing for the foot. We should sort of apply it a little bit here. But then the animation data is just totally malleable, right? It's not sort of sticking around there, you know? That's a different thing, right? As you're saying, that's exactly what you're getting at, right? That part of the other thing about dense animation data editing is that the ability to have assistance that doesn't paint you into a corner is something that I almost feel like you need it for. Like, you can't have that with conventional rigging, I don't think. Conventional keyframe based animation, or maybe you can, but only in very, very limited ways. Anyway, that was a bit of a tangent, but you know, we will get to more of that stuff. You know, when I get back into doing some more ephemeral animation streams, which I'm sure will happen soon, because we've been adding some more features, and there's going to be some cool stuff to show off. But we can sort of talk about that stuff more then, instead of fitting it into the component stream, where it sort of, you know, is a bit of an off topic. Anyway, it is now 6:50. I better get going. But thank you all for coming and watching our stream. We won't be back next week. And actually, unfortunately, it looks like I may not be able to make it to the week after that either, due to various, you know, holiday related things. But on, let's see, what is on the 10th of January, we will be back. And at that time, we'll probably be integrating this into a body rig. And at that point, that'll probably be our last component based stream, because at that point, I think we will have successfully done what we need to do. I mean, that's not entirely true. Like, for instance, I'm not really accounting for making the leg reversible. And maybe we should do that too. So maybe that won't be the last one, but it'll be very close to it. And you know, we will, or maybe I won't do that on stream, because you've seen me do it to the finger. Maybe you kind of get the idea. But so it might be the last one. We'll see. But anyway, please tell your friends, like, they should come watch the Notional Pipe stream. If they like hearing rants about keyframes, and also if they want to understand interesting things about rigging and interesting ways of using contour, and you know, have some of these concepts demonstrated for them, and
also, if you're interested in sort of the fundamental ideas behind programming, and you'd like to hear me rant instead of hearing Raph rant for a change, you can come by the mapping reduction, where I rant about software.
Yeah.
And there's a link in the chat.
And you know, it'll be 5 p.m. on the 10th, and I hope to see you all there. Please like and subscribe.
Yep. Thank you very much, and thank you, Raph.
Yep.
And,
no problem.
Yeah. We'll see you next time. Bye-bye.
Bye.